Welcome back to our second video of section 03, where we're talking about how to factor some polynomials. So, I hope that you still have your notes from the last video. If not, that's okay. These might be a little more difficult to get back into. But our first example for today is example 5 in the notes that you can see down there in the corner. And we're going to factor 4x squared plus 28x plus 40. So, if you've got your notes from yesterday, or if you remember, what is the first step when you're asked to factor something? It's always to try and find the greatest common factor, Gcf. So we're trying to see if there's anything we can pull out from all three of these terms. Is there any number, let's just start with the three numbers here, can we divide all three of these numbers by anything bigger than 1? Yes, we can. We definitely can. What's the biggest number that we can divide them all by? Well, we can divide them all by 2. That's true because they're all even. But I think we can actually divide them all by 4. 4 divided by 4 is 1. 28 divided by 4, that's 7. And 40 divided by 4 is 10. So, for our GCF, we can pull a 4 out of all three of those terms. Can we pull an x out from every term? We can't pull out any x's because this last term doesn't have any x's. So our GCF this time is just 4. But we're going to treat that GCF just like we did in the first couple examples of the last video. The GCF is going to go out front. And then in parentheses next to it, we're going to write what all three of these terms are divided by 4. So let's start with 4x squared divided by 4. And if we need to do that over here, we can. 4x squared over 4. 4 divided by 4, that's just 1, it cancels out. And then we're left with x squared on the top. So this is going to be 1x squared, or just x squared, plus. Now we do 28x divided by 4. And it was helpful when we were trying to figure out what the GCF was that we knew 28 divided by 4 and gave us 7. Because we have to do that here. 28 divided by 4 is 7. And that x is chilling on top, so we're just going to keep it. That's 7x. Plus 40 divided by 4, that's just 10. 10. All right. So, in the examples yesterday, once we pulled out the GCF and wrote what went in here, we were done. But check out what we've got inside the parentheses now. We've got how many terms in here? 1, 2, 3. I think that what's in here can still be factored. We've pulled out the GCF, and that made our lives a lot easier. It turns out it's a lot simpler to factor what's left in here than to factor what we started with. So we pulled out the GCF, we still need to factor what's in here. If you've got those notes from yesterday, or you remember, how do we factor what's left in here? We're looking for two numbers that multiply to the number at the end, 10. And those numbers must add to the number in the middle. The number in the middle term, 7. So we need two numbers that multiply to 10 and add to 7. Might be able to come up with them. If you're having trouble, just start writing down all the pairs of numbers that multiply to 10. 1 and 10, 2 and 5, and that's it. Those are the only ones. And we need our numbers to add to 7, so is it 1 and 10 or 2 and 5? Obviously it's 2 and 5. Okay. So, let's pause here for just a second. All right? The first thing we did here is the first thing we always do when we factor. We looked for a GCF. And there was one. It was 4. So we pulled it out front. And we divided each term by that GCF to get what was in here. But we determined we could still factor what was in here. So all this stuff that we've been doing right now, so far, finding these two numbers, we've been ignoring the GCF because we're dealing with just what's in here. But when it comes to write our answer, we have to remember that 4 is still out front. So it's like we're taking the two things we learned in the last video and putting them together in the same example. So our numbers are 2 and 5. So we got two sets of parentheses here. The two numbers are what go in the back of each set of parentheses. This is a positive 2, so plus 2. Positive 5 plus 5. In the front goes x. Anything missing? Or is this our answer? The 4. The 4. It's still out front. It's still hanging out. So we still got to put it out front. And so that's what we end up with. 4 times x plus 2 times x plus 5. All right. So there's an example where we started with a trinomial that had a GCF, but we were able to pull it out and factor what was left, putting both types of problems together in one. All right. Let's tackle the next one. Let's do it. Let's do it. Example 6. We're going to factor m squared minus 4. This one looks a little different than the last few. How many terms does this have? Just 2. This one had 3 terms, right? It had a term with something squared. We've got that here. It had a term with just the letter with it. This one doesn't have that. And then it had a term that was just a number. That's here. So the thing about this is it's missing that middle term. But since we already know how to factor stuff that has 3 terms like this, let's write this with 3 terms. And we know it's the one in the middle that's missing, so we'll leave a little hole there. We're going to be writing a term in here, but we can't just put anything we want there. It's going to be something m, right? We're just going to be putting a number in front of that m. But that term is not here. So if we want to put a number in front here, but there's nothing here, what number means nothing? 0. So let's just write this as plus 0m. We can do that. It's one of the great things about math. You can put a 0 anywhere. Well, except for the denominator of a fraction. Then things kind of get weird. But since there's no m's in here, we can write that as no m's. 0m. And now we can factor this just like we did here. Well, first we would look for a GCF, right? Is there a GCF here? Is there anything we can pull out from all 3 terms? Can't pull out a number because this doesn't have anything in front. Can't pull out any m's because this last term doesn't have any m's. So there's no GCF here. That's perfectly fine, at least we looked. Now, we go to step 2, which is to find 2 numbers that multiply to the 2 numbers we're looking for. Always multiply to whatever the last term is. And remember, this negative sign goes with the 4. So our 2 numbers, whatever they are, need to multiply to negative 4. and they need to add to 0, the number in the middle term. So our two numbers had to multiply a -4 and add to 0. Interesting. If the two numbers we're looking for add to 0, what has to be true about them? They've got to be opposites, right? Like positive and negative, the same number. That's the only way that they'll add to 0. So what two numbers multiply to -4 but add to 0? I'm getting -2 and +2 vibes. But, again, we can write out all the numbers that multiply to 4. 1 and 4, 2 and 2. And we know one of the two numbers has to be negative if this multiplies to a negative number. So, how are we going to get them to add to 0? It has to be 2 and -2. Those are our two numbers. So, once we have our two numbers, we can write our parentheses where the numbers are going to go. They go in the back. -2 here, +2 there. The letter we're looking for is M, so that goes in front, and there it is. Turns out when you factor m squared minus 4, you get m minus 2, m plus 2. Now, some teachers will tell you a shortcut, that you can go straight from here to here. But it requires that you know that these are both something squared. And I don't necessarily want you treating this as a special case. I'd rather you think of it as just putting 0m in the middle and treating it like all the rest. Okay? If you want to use a shortcut, if you've got two terms like this that's missing the middle term, and this is a squared number, this is 2 squared, then you know that the numbers here are going to be opposites. You can go straight to the answer. But again, especially if you've struggled with factoring in the past or you didn't remember what it was, I think this is the safer way of figuring this out. I think it's the better way. Okay. So, we're most of the way there. There are just a couple more examples that I want to talk about, and they're a little different than the ones we've done. But I think we've built a decent foundation that now we can build on. So, let's tackle example 7. Example 7. Let's check it out. We want to factor 6p squared plus 7p minus 3. Step 1 is always the same. Doesn't matter what it looks like. If it's asking you to factor, step 1 is to try and find a GCF. Always. Okay. Take comfort in the fact that your first step when you're asked to factor is always to find a GCF, if there is one. Is there one in this case? Are there any numbers that we can divide into 6, 7, and -3? Nope. 7's the problem there. You can't really divide 7 by anything. Can we pull out a p from every term? Nope, this one doesn't have it. So we don't have a GCF again this time. But that's cool. That's all right. Now, the reason this one's different is this is actually the first example we've had where after we looked for the GCF, this leading coefficient, the number in front, was still bigger than 1. Take a look back at all the other 6 examples we did. Oops, sorry. I meant to scroll this down a little bit. We're now on example 7. Okay. In every other example, either the leading coefficient was already 1, or it wasn't, but when we pulled out a GCF, it became 1. So this problem is a little different. And there are several different ways of attacking factoring a polynomial that has a leading coefficient other than 1. Because this is e-learning, I'm only going to teach you the way that I think works best for the most students. It's called the box method. And here's how it works. Draw a box. Just draw a nice square, big enough so that if you split it into 4 quadrants, that you can write terms in each one. Each of these is going to have a term in it. And remember, terms are like these things. So make it big enough so that you can do that, but not too big. Okay. There are 4 boxes in here. In this box, the upper left box, you're going to put whatever the first term is of the original polynomial. So the first term here is 6p squared. That's going to go in here. In the bottom right corner, in this box, you're going to put the last term. And remember, the negative sign goes with this 3. So negative 3 is going to go right there. Those are the 2 easy boxes to fill in. And I know this looks really different from what we were doing, but this is still factoring. It's just a way that is visually appealing, so that the steps are somewhat easier to remember. So, once we have this, what we're going to do to try and figure out what goes in these 2 boxes, we're going to multiply these 2 numbers together, the 2 that we've already put in boxes. So we're just going to multiply 6 times negative 3. Multiply. Multiply. So we're going to multiply 6 times negative 3. Sorry, that's a negative sign. There we go. 6 times negative 3 is negative 18. Okay. So, the nice thing about the box method is, at some points, it's actually very similar to how we did these. This number that we just found, we're still looking for 2 numbers, just like we were in these examples. This number here is what our 2 numbers need to multiply to. Okay. Back in those problems, the number that we needed to multiply to was always just the last number. Well, it was here. But if this leading coefficient is something other than 1, it's actually these 2 numbers multiplied together that they need to multiply to. And our 2 numbers will also add to the middle number, just like they did here. Just like they did here. Okay? So this time they need to add to 7. So, we are looking for 2 numbers that multiply to negative 18 and add to 7. And that's going to help us find out what we're putting in these 2 boxes. So, see if you can find those numbers. Pause the video if you have to. Come back when you're stuck or you got it. I'm just going to write out all the pairs of numbers I know that multiply to 18. 1 and 18, 2 and 9, 3 and 6. That's it. And if I was doing this and I was being really careful about it, I could have stopped when I saw 2 numbers that could add to 7 if one of the numbers is negative, which it has to be, right? So how are we going to get to 7? 1 and 18, they're too far apart. 3 and 6 are too close together. But 2 and 9, which number is negative? The 2, right? Negative 2 and 9 makes 7. If you made the 9 negative instead, you would get negative 7. But they add to positive 7. So our 2 numbers are negative 2 and 9. So these 2 numbers go in these 2 boxes. And it doesn't matter which one goes which place. Doesn't matter. Negative 2 and 9. The thing about these 2 boxes is we can't just put the numbers in there. We also have to put the letter in the problem. What we're doing with these 2 boxes is we are splitting 7p into 2 pieces. You can think of it that way. we're splitting 7p into negative 2p and 9p. We're just splitting that term into two pieces and putting it in these two squares. Okay. So we're actually almost there. Once you've got everything in the box, you're in pretty good shape. All you have to do from here is something we've already done in other problems. Something we've already tried to do in this problem. We need to find the GCF of each row and each column of terms. So let's take it one step at a time. These two terms right here, 6p squared and negative 2p. What's the GCF of those two terms? The biggest thing you can pull out from both. I think we can pull out a 2. So we'll put that out here. And we can pull a p out as well. So we can pull out 2p. So we'll just put that right out here. Let's find the GCF now for these two terms. Biggest number that you can divide 9 and negative 3 by? About 3. Can we pull any p's out from both? Not in this case, because there are no p's here. So we've got 2p and we've got 3. We also need to find the GCF of the two columns. So let's do these two terms first. Biggest thing we can divide 6 and 9 by? They're both divisible by 3. Can we pull any p's out? We can. We can pull out a single p. Last ones. We need the GCF of these two terms right here. What is the biggest number we can pull out of negative 2 and negative 3? Well, there's not really a number we can pull out, really. But since both of these numbers are negative, I will say we can pull out negative 1. Okay, that's the only time you'll be able to pull out a negative 1 is if they're both negative, but they don't really have a GCF. You can pull out a negative 1 here. And we can't pull out a p because this doesn't have one. So we've got 2p, 3, 3p, and negative 1. Once you've got all 4 of these GCFs, you're ready to write the answer. I know this is a long process. This is not an easy problem, but you're writing notes, you're following along, you're getting there, you're seeing how it works. We're going to take these two things and put them together in one of the parentheses. So we've got 2p and a positive 3 plus 3. Can you guess what goes in here? Three p minus 1. And there it is. If you can do a problem like that, you've earned it. I'll tell you. It is not easy. There are quite a few steps to go here. Well, I mean, we're done. There aren't any more steps to do this problem, but there are quite a few steps to go from here to here. But I think by using the box method, I think that will help you out. You only need to use this method if you try pulling out a GCF and this number is still bigger than 1. You can use the box method for any of the ones we've done in the past. It's just not necessary. I personally tend to think that it's more work than it needs to be for problems like the ones we did earlier and in the last video. But if you're comfortable and you want to use the box method every time, go nuts. You can. It always works. But I just like using it when this number is not 1 after you pull out a GCF. All right, so you've seen it once, and if I stop now, this video would still be kind of long, But we learned a lot here. But I do want you to see another example of this. So if you need to get up and do something, if you just want to stretch, take a little bit of a break, promise to come back for one last problem so you can see how this box method works for a different example. All right, if you left and came back, awesome. Let's tackle this last one. If you stayed too, awesome, cool. This will just take a few minutes. I promise it'll be worth your time. GCF first. We want to factor this. Look for a GCF. Any numbers that we can divide 4, 20, and 25 by? Nope. Can we plot a B? Nope, this is just 25. So, there's no GCF here. My apologies, I should have scrolled this down a little bit more. This is the last example in our notes here. No GCF. And notice, we still have a number here bigger than 1. So that is your cue to use the box method. Draw your box. If at any point going through this example you want to do the next step on your own or try the rest of the problem, pause the video, try it, see what happens. What's the worst that could happen? You screw up, hopefully you're writing in pencil, you can erase it and fix it. This is the time to try stuff out. Okay, so feel free to pause at any time if you feel good about the next step. Doing a problem like this correctly can be a huge confidence booster. Remember what you can put in the box right away? First term goes in this box. Last term in this box. Okay? That is specific. It does matter which box these go in and which terms you pick. We need the other two boxes. How do we get them? Look back at the problem we just did that was very similar. Once we had these two squares, we multiplied 6 and -3. Where did those numbers come from? They were the two that were in the box already. So this time we're going to be multiplying 4 and 25. That's 100. So we need two numbers that multiply to 100. And add to what? Yeah, 20, the middle number. So two numbers that multiply to 100 and add to 20. My apologies if you hear any background noise, it's a little loud. Sorry about that. Let's see. 1 and 100, 2 and 50, 3 doesn't work, 4 and 25. As I'm writing my pairs of numbers, because I don't know which two numbers work right away, I'm keeping in the back of my mind, I want these to add to 20. These are still too far apart. 5 and 20 multiplied to 100, still too big if I add them together. 6 doesn't work. 7 doesn't work. 8 doesn't work. You can do this on a calculator, by the way. You can do 100 times 6, 100 divided by 6, it'll give you a decimal. 100 divided by 7, decimal. 100 divided by 8, decimal. 100 divided by 9, decimal. 100 divided by 10, that works. 10 and 10. We need our two numbers to add to 20. So the numbers are 10 and 10. 10 and 10. So 10 and 10. Anything else need to go in those two boxes? The B's. Each of these needs a B. 10B, 10B. All right? We're close. We're close. Once our box is filled out, we need to find these things, the GCFs of each row and column. And you can do them in any order, doesn't matter. I usually start here. Biggest number we can pull out. Can't divide by 4 here. 10 doesn't divide by 4, but 2 works. And these both have a B that we can pull out. Biggest thing out of these two. Can't divide them by 10, but you can divide them both by 5. Can't pull a B out from this, so it's just 5. GCF of these two terms. Biggest number, oh wait, the GCF of these two is the same as the GCF of these two, right? It should be 2B, because this box and this box are the same. And then GCF of these two, that's the same as the GCF of these two, which was 5. Okay, we've got all of these things. Let's get the answer. Let's get the answer. We've done all the work. 2B and positive 5. 2B plus 5. This is also 2B and positive 5. 2B plus 5. So it turns out, in this example, we actually get the same thing in both parentheses, and that's perfectly fine. That is totally okay. If we were to FOIL this back out, we would get that. All right? So I apologize, this video was super duper long, but I hope it's been worth it. We continued learning how to factor some of these more basic polynomials, but we also learned how to use the box method for when this first number, this leading coefficient, is bigger than 1. All right? At this point, I could give you any trinomial, any polynomial with 3 terms, and if it's able to be factored, you now have the tools you need to factor it. And that's a good thing, because now that we're done with section 03, you've got some problems to work on your own. I'm not necessarily going to give you a day just to work on those problems, because I do have office hours every day that you can come and talk to me. Okay? Just shoot me an email. Let me know that you want to work on a problem, and we can talk on Zoom, or I can help you out through email, whatever it is you need. You will get as close to immediate response as possible if you contact me between 11 a.m. and 1 p.m. any school day. Between 11 and 1, I'll get back to you as soon as I possibly can. Other times of the day, I'll still get back to you, but it might take a little longer. But since I'm available every day like that, I won't necessarily give you an entire extra day just to work on the problems, because you can contact me every day already. So, take a look at those 03 problems. They'll be due in a couple days from when this video is assigned. And let me know if you have any questions. I definitely want to help you if you're struggling. Some of you have already reached out to me. I hope you thought it was worth it. And I hope to see more of you as the semester goes on. So, for now, thanks for watching, and we'll see you next time.